Now we're going to talk about combinations and the binomial theorem. I have this page, it's the last page that we did, handy because we're going to use it. So on the top of the page, this is the rule for combinations. Combinations can be written as two different ways, and you'll see them both here. First, it's n over r. It looks like a fraction, but no line in the middle. So if you see like 6 over r with no line, that's a combination question. The other way you might see it written is NCR, a number first, a big C, capital C, and then a number second. And those two ways to write it is a question for combinations. And combination means if you have n items, how many ways is there to choose r of them? So for this question, it's if you have 6 items, how many different ways is there to choose 4 of them? This is if you have 3 items, how many different ways is there to choose 1? So a couple different ways to answer these questions. First, you can look in the Pascal's triangle. All of these are answers to combination questions. What you do is you start by looking at the top number, and that's going to be your row number. And the bottom number is your diagonal number. So for this question, you go to the third row, the first diagonal, and that is your answer. There are 3 ways to choose 1 item from a group of 3. Now we'll do the 6th row, the 4th diagonal. So 6th row is here, 4th diagonal is here, so it's 15. There are 15 ways to choose 4 items from a group of 6. We don't have the 10th row or the 7th diagonal, so I'm going to show you one last way to answer combination questions. You can use your calculator. What you do is you start by typing in the number 10, then you hit Math, over to PRB, go down to NCR, and the 10 is the top number. Then you type 7 as the bottom number, hit Enter, and 120 is your answer. That means there's 120 different ways to choose 7 items from a group of 10. This is going to help us do the binomial theorem, and the binomial theorem is a shortcut for expanding binomials. And expanding binomials means taking a binomial, which is like x plus y or 2y minus 3. It has 2 different terms in parentheses with an exponent here. Expanding it means writing it not in parentheses. And what we're looking for is a shortcut, because a long cut would be x plus y, x plus y, x plus y 5 times, foiling, distributing, combining like terms. It would take a long time. Okay, so what we want is a shortcut. The shortcut is not distributing the 5th power. That is not what it is. The shortcut will be the binomial theorem, and I'll show you that. I will do the definition here after we do a couple of examples, because it's easier to see the examples than the definition. So with the binomial theorem, it's going to be 3 separate steps. The first step is to look at the 5th row and write those numbers down. So the numbers are 1, 5, 10, 10, 5, 1. I spread them out quite a bit and I almost ran out of room, but that's the first step, is to take that 5th row and to write it down. The next step, I'm going to switch colors to make it easier to follow, is to take the first term and write that next to each of these numbers, but you're going to start with x to the 5th power. And then reduce by 1. X to the 4th power, x to the 3rd power, x squared, x, and by the last number, you should run out of room. The 3rd step is to take the 2nd term, which is y, and start at the end. Y to the 5th, y to the 4th, y cubed, y squared, y to the invisible 1, and then you should run out by the last one. So, like I said, the long way would be to write x plus y 5 times and FOIL and distribute and combine like terms forever. It would take you a long time. This is the shortcut, and this is your final answer with pluses in the middle. So an expanded binomial of x plus y to the 5th is 1x to the 5th plus 5x to the 4th y plus 10x cubed y squared plus and all of this. This is all of your expanded binomial. With this one again, you could write 2y minus 3 4 times. You could FOIL and distribute and combine like terms and do it the long way, or use the binomial theorem, and I'm going to use those same 3 steps. The binomial theorem says first, take that exponent number, find that row in Pascal's triangle, 1, 4, 6, 4, 1, and write that out. Second, I'm going to take the first term in the binomial, which is 2y, and I'm going to write it to the 4th power, because that's a 4, and then the third, and the second, and the first. I actually don't need that 1, because you don't need 1s as exponents, and then you should run out. Then I take the -3, it's like plus a -3, and I start on this end. -3 to the 4th, -3 cubed, -3 squared, -3 to the invisible 1, run out. This would be the answer, but this question requires a little more simplifying before we're done. But this is my 3 steps. Row 4, that to the 4th, 3rd, 2nd 1, that to the 4th, 3rd, 2nd 1. This one I do have to do some cleaning up, a little bit of simplifying. And when you have 2y to the 4th, you can distribute that 4th, so that would be like 2 to the 4th, y to the 4th, and 2 to the 4th is 16. 16 times 1 is 16, so this term here becomes 16 y to the 4th. If you have a number to the 4th power, I want you to figure out what that number is. If you have a letter to the 4th power, you just leave it. Now I got to work on this one. I've got a 4. I've got a 2 cubed y cubed, and I've got a -3. So 4 times 2 cubed times -3 would be -96, and then I've got that y cubed. So I multiply all my numbers to get the -96, and then I have my letter y cubed. This one's got even more, well, about the same. So I'm looking here, I have a 6, I have a 2 squared y squared, and I have a -3 squared, which is 9. So I have 6 times 2 squared, which is 4 times 9. So I have 216, and I have a y squared. All right. Next I have a 4 and a 2y and a -3 cubed. -3 cubed is -27. So I've got a 4 times 2 times -27. That would be -216 y. And last I have 1 times -4 or -3 to the 4th power. 1 won't change it. -3 to the 4th power is 81. So when I'm done simplifying, this is what it ends up looking like. So what I've done is I've walked you through the process 2 times. Now I'm going to write the definition here. And you might not ever even have to look at this if you just kind of remember how to do the row and the terms and the exponents. But here's what you would see like in a textbook for a definition. We start with the nth row of Pascal's triangle. And if you don't have Pascal's triangle, another way to think about it is with combinations. So because all of these are combination answers, the first one in every row is NCN. The second one is NC1. I'm sorry, I'm going to start with NC0. NC0. And then NC1. And then NC2. And then you'll keep going until you get to NCN. So again, that is going to be Pascal's triangle. All of these are combination answers, so you can write them as combination questions. Then you take your x, and it's x to the n minus 1, x to the n minus 2, etc., all the way until the last one should be x to the 0, which is 1, which is why you run out at the end. Then you take your second term, which is y, and it'd be y to the n minus 1, y to the n, and as you get all the way to the end, you should have y to the 0. Second to the end is y to the 1. Third to the end is y squared. So this would be the definition on how to do any binomial theorem expansion.